Okay, let us go through the important points and formulas. So whenever you see two force and the line of action of each of them are in parallel like this, if you find the distance between them, and remember these forces should have the same magnitude. I mean, if this is 100, this one should be also 100, the magnitude, but in opposite directions, okay? Then you can equivalent this one, these two forces, with a moment. And how can we obtain the distance? Easy. This one should be right angle. This angle also should be right angle. Not like this. This one cannot be the minimum distance. The minimum distance is the distance that is right angle with a line of action of each of these two force vectors. So, for example, if this is 1 Newton and this is also 1 Newton, and the distance between these two is 1, so the moment will be 1, but since it is in clockwise, it will be negative 1 Newton meter or 1 Newton meter clockwise. Okay, now let us go through the questions. This is the first questions. It says that we have each propeller of the twin screw ship. So this is a twin screw ship. It means that it has two propellers. This is called propeller. Okay, you see each propeller has 4 blades. It says that it develops a full speed thrust of 300 kilonewtons. So each of these, as you see, they are rotating in opposite direction with respect to each other, so they will force the ship, one of them in this way and the other one, for example this one, forcing this way. Okay, so you cannot see the propellers here because you are looking the ship from above, but they are here. But for example, this one is here and this one is also placed here on the bottom. Okay, now it says that, so now based on the point that I mentioned, so when we see two forces, they have the same magnitude and in the opposite directions and the line of action are parallel, you know, you have the distance. So the moment for this one will be 12, which is distance, times F, which is 300 kilonewtons, and for kilo we just put 1000s. So this is moving in clockwise, so it is negative. Instead of these two forces, we will just put a moment about any points. It doesn't matter. Now let us finish the question. In maneuvering the ship, one propeller is turning full speed ahead and the other full speed in reverse. It means that it is just rotating this way and this is rotating this way. What thrust P must each tug? Okay, this is called tugboat and this is called also tugboat. For example, these three, we have 3 tugboats or tug, and they are forcing in these directions. This one, for example, forcing in these directions, and this one in these directions. And here, this one is applying a force in these directions. I will show you in the next slide. So now this is very important. You need to have a system. So the ship is now this system or body that we want to see what are the forces that are applied to this. This is very important. You will see that in the next questions. So we assume that instead of this tug force, we just put the force, which is in this way, and this one is also in this way, and we assume that they have the same magnitude. So again, these two are in parallel, and we have the distance between them, which is 120 minus 50, which is 70. Okay, do not look at here. This is another way that students use, but I will not recommend this way. I will tell you why. So now I will just write, for example, instead of these two forces, as I mentioned, I just put 300 kilonewton. Kilo, I just put kilo, but you need to know that kilo means 1000. Okay, or you can write 1000s, and the distance is 12. So is it clockwise or counterclockwise? It is counterclockwise. I will just add negative because it is clockwise, sorry, and this two is counterclockwise. So I will just put the P times what is the distance between the line of effect of these two forces, 70, is equal to 0. Why equal to 0? Because this ship is now stationary. It doesn't move. It doesn't rotate. Okay? So now I obtain the P easily. Okay? And if you are smart, you will just get rid of this 0. Okay? And also one of the 0 here. Okay? Now we will use our calculator, or you can just write 30k times 12 divided by 7, and because I move this one, the negative will be positive, and yeah, the answer is this. You see that I didn't change k, it should be in lowercase, and then here now you can put 1000 because I don't want to occupy my brain. Now you can use your calculator. So times 12, let us show you how I work with this. And again, I don't use k here, which is 1000. I will tell you why. So 51.4. Now I just move the k here. K Newton. Okay, the answer is this. You see, I didn't even touch this one. Now I want to talk about the second method that some people use. Okay, some people say this. They said, okay, we will consider one point from here, any point actually, and we will obtain the moment of each forces about this point. So we have the for example, for this one, it will be P1 times 50, and it is clockwise, so it will be negative. So P1 is equal to P2, so I'll just put P, so the answer will be this one. Okay, and now for this force, again, this will be P times 120, because it is counterclockwise, it will be positive. And again for these ones, so this will, the distance between the line of effect of this one is 6 meters times F, which is 300 kilonewton, so it will be negative. Okay, but I don't like this way because it takes time. Okay, yeah, which, I don't know, some people, yeah. Okay, so remember these ones. I want to get rid of the colors. So, and for this one also will be negative 300 kilonewton times 6 meters. So you don't need to put Newton here, because it might make you a little confused. Yeah, this is the method. Then you can obtain the P. So this is the second method.